This video presents MELA and SYBL. We showcase their functioning on an M2M application, deployed on our local cloud. The application description can be submitted through Tosca, or using the model defined for our SYBL. Therefore, we specify which are the service units, how they are grouped together into service topologies, and what is the relationship between them. For this demo, the cloud service is composed of an event processing service topology, and a data end service topology. The cloud service description also contains SYBL elasticity requirements, at the different levels of the cloud service. For the data end service topology, constraints CO1 and 2 specify that the latency should be less than 0.5 and the CPU usage should be below 83%. For the event processing service topology, constraint CO3 sets response time less than 350 milliseconds. Strategy ST1 sets as goal for the event processing service topology throughput maximization when cost is less than 50 cents. Strategy ST2 recommends the scale in action when the response time and throughput are high, while ST3 considers CPU usage. The deployment descriptor contains information regarding the deployed topology and can be received from a deployment system. This descriptor links initial deployment topology with a virtual infrastructure and can also provide information necessary for the control of the cloud service, like default flavor to use or the image on which artifacts are deployed. After starting the clients, the response time gradually increases. The workload which we use is repetitive and consists of varying the number of requests in a Gaussian pattern. Since the response time should be less than 350 milliseconds, and the strategy ST1 states that the throughput should be maximized, the SYBL control system decides on adding a new virtual machine for the event processing service unit. Since constraint CO2 is violated, the SYBL controller decides on adding a new virtual machine for the data node service unit. The latency for the data service topology is composed of latency for each of its service units, which at their turn depend on the latencies for each virtual machine on which they are hosted. MELA aggregates low-level metrics to complex ones, associated with the service unit, the topology, or the entire cloud service. MELA also provides mechanisms of tracking metric composition. For instance, the cost per client per hour for the entire cloud service is composed using the cost for each of its topologies, and the number of clients of the cloud service. The cost may vary with the number of virtual machines, or with the number of input-output operations. MELA also provides features for metric correlation and history analysis. It enables the user to check what are the boundaries for the other metrics, when the received restrictions were respected. For instance, we can know under what number of clients the response time restriction was respected for the current control system configuration and service runtime configuration we had so far. This kind of information would improve the decision quality for the SYBL control system. Each time the SYBL constraints are violated, or the SYBL strategies are triggered, new actions are generated for fulfilling the described elasticity requirements. When strategy ST2 is violated, due to the small throughput and small response time, which usually means that there are few clients and the cloud service is over-provisioned, the SYBL control system can trigger a scale-in action. Since their response time should be less than 350 milliseconds, and the strategy ST1 states that the throughput should be maximized, the SYBL control system decides on adding a new virtual machine for the event processing service unit. Since their response time should be less than 350 milliseconds, and the strategy ST1 states that the throughput should be maximized, the SYBL control system decides on adding a new virtual machine for the event processing service unit. When strategy ST2 is violated, due to the small throughput and small response time, which usually means that there are few clients and the cloud service is over-provisioned, the SYBL control system can trigger a scale-in action. Therefore, with simple elasticity requirements, one can monitor and control, using MELA and SYBL, complex cloud services. More importantly, with the help of MELA, cloud service developers can understand their application behavior. This enables them to specify good SYBL elasticity requirements, which will improve their service behavior, both in terms of quality and in terms of cost.